So let's complete this part. This is the part 2 of what we were doing yesterday. Investigating compounds. Can you hear? Can you hear?
Yes, I can hear.
Investigating compounds. So how do we investigate what type of compound is or what type of elements are found in a given compound? Now, normally we say scientists, they analyze substance to find out what those substances are made of, what those compounds or substances are made of, and they usually use two techniques. They usually use two techniques to do this. One is the qualitative analysis technique, and the second one is the quantitative analysis technique. Qualitative and quantitative. Okay, now the qualitative tells the scientist what elements are found in the substance, what kind of elements are in the substance. That's the qualitative analysis. The qualitative analysis helps to tell the scientist what type of compound, what type of elements are found in the compound. While the quantitative analysis, they tell the scientist much of each element in the compound, how much of each element is found in the compound, how much of each element is found in the compound. Okay, so the quantitative tells the scientist how much of each element is found in the compound. So which means if you have a compound, so it's so big. Okay. Let me erase this first. So big. Okay. Let's say if this is a compound, if this is a compound, we're going to find out, we have two ways of finding out what element is made up of. We have two ways. The first way is the qualitative technique, and the second way the scientists use is the quantitative. So there are two ways. One is qualitative technique, Qualitative tells us what the compound is made up of, what element. Qualitative, it tells us what element is the compound made up of. Qualitative analysis tells the scientist what element the compound is made up of. For example, if the compound is sodium chloride, okay, it tells the scientist, okay, this compound is made up of sodium and chlorine. It's made up of sodium and chlorine. Then why the second method, let's put it in bracket, the second method tells the scientist, that one is called quantitative, tells us how much quantity of each element is found. Quantitative, it tells the scientist how much quantity of each of the elements. Maybe sodium is 10%, maybe chlorine is 90%. So it tells the scientist how much quantity, how much percentage, how much of each of the elements is in the substance. That's the quantitative techniques. Is that okay?
Yes.
Okay.
Yes.
Okay, so now let's move on. So, and how we do this, how do they know each of these elements? If you now find out, okay, there's sodium, there's this, how do you know it's sodium? Because it's a compound, it's a mixture of different elements. A compound is a mixture of different elements. So how do the scientists know that, oh, what we have here is sodium, what you have is chlorine, what you have is this. With the element, the constituent element, how do the scientists know that these various or these individual elements are what we have named them? Maybe they are lithium, they are barium, they are boron, they are oxygen, they are. So they can't tell unless they carry out some tests. One of the way is to do what we call the flame test. Now, the flame test, what the scientists do is that in the flame test, it has to burn the metallic element. When you burn the metallic element, they will make flames of different colors. Okay, so the scientists have to burn them. So when you burn them, like the way you burn candle, when you burn them, they will make flames of different color. Now, the color tells you what element it is. The color coming out from it tells you what element it is. Is that okay? The color coming out from it tells you what element it is. Now, for example, let's take a look at them one after the other. For barium, what color do you see from barium? When you burn barium metal, this barium metal, when you burn it, what color do you see from this?
Yellow.
This is yellow, right? So it gives a yellow flame. It gives a yellow flame. So barium gives a yellow flame. Sodium gives what color is this?
Orange.
Orange. Sodium gives an orange flame. And what color is this? Calcium gives a red flame. Copper gives a blue flame, right? This is a blue flame. And then potassium gives a purple flame. So take note, when you're going to be naming them for me. I'm going to ask you, I will leave this page and I will be asking you. So barium gives what? Yellow flame. Sodium gives what? Orange flame. Calcium, but this is not completely orange anyway. Calcium gives a red flame. Copper is blue. Potassium is purple. Now let's have this test. Let me see characteristically if you are there. Now let's see this. Now let's start with the first one, barium. What flame?
Yellow.
So barium gives
Yellow.
Okay, barium gives. Okay, we'll be writing the symbol. So barium, I will just write BA, right? Okay, barium gives a yellow flame.
Yellow.
So when you burn a metal and it's giving you a yellow flame, so it's probably what? Or maybe here I should have taken yellow. Let me use yellow to symbolize it. Barium gives a yellow flame.
Click.
Yellow. Which of these is yellow? This one, right? Right?
Yeah.
Okay. Barium gives a yellow flame. Sodium gives what?
An orange face.
Orange.
A yellowish orange flame.
Sodium is Na, right?
Yes.
Sodium is Na. Is you'll be wondering why not the symbol? Why is it not S or SO or SD? No, because the name is derived from the Latin name, latium. The name is derived from the Latin name, latium. What's the color of sodium again?
Orange.
Orange.
So let's find orange color here. Let's find orange. Do we have orange here?
Yes.
This?
No.
This one. Okay. So sodium gives orange flame. So whenever you burn a metal and it's giving you an orange flame, then obviously it's sodium, right? Okay. Now let's go to the next one. Which other one?
Calcium.
Calcium. Calcium is Ca. What color was calcium again?
Red.
Okay, so calcium gives red flame. So let's pick red color. Calcium gives a red flame. Now here is red. Where's red here? This one? This one looks like orange. Really? Okay, so calcium gives a red flame. Then, which other element again?
Copper.
Copper.
Okay, copper is Cu, right?
Yes.
Copper is Cu. Copper gives what?
A green flame.
A blue. Oh, I should have written it with black. Since it's giving a blue flame. Okay, let's change that. Copper gives. Copper gives. Let's write it with black. Then the flame we write with blue. Copper Cu gives what? Wait, this is for paper 6 for Cambridge IGCSE. So please pay attention. Copper gives a blue flame. So let's take the blue here and write blue. Okay, which other element did we mention?
Potassium.
Potassium.
Potassium. Potassium is K, you know, right?
Yes.
Potassium is K. Potassium is K. So which color? Purple. Okay, now let's look for purple color here. There's purple. Okay. Potassium gives a purple flame, right? I think we still missing one metal. Can you check? We still missing one metal. We did for barium, for sodium, for calcium, for copper, and for potassium. Okay, I think we've looked at the ones that is itemized here. So please keep bear in mind, barium gives a yellow flame, sodium gives an orange flame, calcium gives a red flame, copper gives a blue flame, potassium gives a purple flame. Please, this is very important. You need to know, okay? You need to know this super. Now let's move on to the next one. Let's move on. Okay? Okay. So we go see this how they burn. Now let's take a look at the experiment. Okay, there's more lithium, strontium, lead, barium. Barium in this case is a different color, right? Looks like green. Yeah, it's a lime green. It was not a yellow color. I think barium was a lime green. Look at it. Look at it here.
Oh yeah, top looks like was burning.
Yeah.
Like white line.
Yeah. Look at it. Okay, now let's say dip the wire loop into the substance to be tested. You dip the wire loop into the substance to be tested, and then hold the wire loop in the hottest part of the Bunsen burner or the Bunsen flame. Hold it, and then you see the color. So you dip it in the substance you want to test, and then bring it to the flame and see the color that will come out. Look at the color of the flame. Okay, you look at the color of the flame. It starts changing.
Same for compounds.
You first of all have to identify every element in the compound and test for each element. You cannot just test for a compound. You have to test for each element in the compound. Is that okay? So sodium is the one that has something like yellow. I think we need to look at this again. Say how to carry out the flame test. This is how to carry out the flame test. You see, they melt the solid, they melt the metal, and then you dip this thing to test it. The wire, you dip it here, and then you put it on the flame, and you see the flame will start to change color. to the color of that metal. Okay, sodium is yellow, potassium is purple, as we said, calcium is red, as we said, lithium is what? What color is this one?
Pink.
Is this pink?
Magenta. Pink.
Magenta. Magenta, yeah, this is magenta color. Okay, the copper is blue, like we said, and strontium is, I think strontium is red also, and then lead is dark blue, and barium is light green or lime. Okay, so let's go back to that and fix. So take note, you're going to tell me. So let's use this one to complete what we were doing before. Let's have a look at that. Okay, let's have a look at that. Now let's fix this. Barium is not yellow. Can we erase that? Barium is what? What color is barium?
Barium is green.
Is it lime green or we just say green?
Lime.
Lime.
Okay, barium. Barium is lime. Okay, barium is lime, so or lime green. Okay, which other one? Sodium was what?
Yellow.
Sodium was yellow or orange? Is
Yellow.
yellow, right? Sodium is yellow. So let's fix that. Sodium is yellow. Sodium is yellow. Sodium is yellow. Sodium is yellow. Then which other metal do we have there?
We have lithium. Pink.
Lithium, right?
Yeah.
We have lithium.
That's not what you said.
Lithium is Li, right?
Yes.
What's the color?
It is pink.
Pink.
This one. That's purple.
Okay, pink. Okay, pink color. Then which other element do we have?
We have lead. Dark blue.
Lead.
Yeah.
Leed.
Okay, lead. You know the symbol?
L.
No.
Le.
No.
LD.
It's PB.
What?
Yeah, find out. PB. LED. Lead is PB. Okay, so what's color?
Dark blue.
Dark blue.
No.
Dark blue. Do you have it here?
Is this or this?
This one's lighter blue. You have to use this one. Erase
Okay.
this one and use it. Right. This one, write dark blue at this
The
color.
one they call blue black.
Dark blue.
Okay, dark blue.
Blue that's dark blue. Then this one you erase it and make it a lighter blue.
Okay. Dark blue. So copper, let's change the color of copper.
Erase.
Let's change the color of copper. To light blue or lighter blue. Okay, which other element do we have?
We done everything. No, we have
Strontium. Strontium, right?
strontium.
Strontium. Okay, can someone check the... Can you check the...
SD. I don't come like this.
Huh?
No,
strontium. Check the symbol in your periodic table. Strontium. Okay? So what color is it? Red, right?
Yes.
Red? Okay. Red. Okay, so all of this is what we test for. And if once you know their color, then you can do the qualitative analysis for all of this. Is that okay? Now let's move on. Let's move. We spend some time here. Let's move on. Now, to do the flame test, scientists they have to put samples of the compound on the end of a loop of a clean wire. So you dip a clean wire in a test tube that has it, and then you bring it to a Bunsen burner, as we've explained before. Okay, the wire is then placed in the flame of the Bunsen burner, and then the flame changes the color depending on the element that is being tested. So depending on the element that you are testing, then the flame will change the color. The Bunsen burner flame will change to the color of the metal. We change to the color of the what? Of the metal. Okay, now let's take a look at this is doing a flame test like we have described. So I expect some of us to try. You test for a solution of barium, calcium, copper, lead, potassium, and sodium. Okay? We can do the test and see what color we're going to see. Whether it matches with the color that we've just described. Is that okay? And then you have to follow safety. You have to wear safety glass because you'll be doing with, you have to wear a heat-proof mat. You have to wear safety glasses. We have to use a Bunsen burner. We have to use talks. Okay? So to carry out and find out this, okay? Now the method, I've already explained the method, and then we keep the result, the color from this. So here are some questions for you to try. You say, identify elements in a compound. Use the results of your experiment and the information in figure 7.8 to predict the flame test, the flame color that will be produced if you test for the following compound. Barium chloride. So the color of barium, right, for the cation, the barium, will be what? What color was that of barium again? Huh? Lime, right? Lime. Potassium is what? Purple, right? Sodium is what? Yellow, right? Sodium chloride, sodium sulfate, and so on. Potassium, chromate, and so on and so forth. So when we do this experiment, we see which color will come out from each of this one. Is that okay when we do the experiment? Okay, look at potassium chloride, what they get. Look at sodium chromate, chromate, like yellow. Look at cobalt sulfate. So for each of them, look at different colors. Ammonium dichromate, look at the color. Nickel sulfate, look at what we get. Ammonium sulfate, look at the color, what we got. Okay, so carry out a flame test to see what color will be produced from each of these. Take the substance, put it in a powder form, mix it with water, dip a tub into it, and use it to put it on the flame and see what, when it burns, what color will be produced. What color will be produced. Is that okay? Okay, now let's take a look at, see, same here, same goes to all of this. Same goes to all of this. So let's just, say, what color do you think is associated to each of these, the copper? What color is copper again?
Copper is
Blue, light blue, right?
yeah.
Okay, what of nickel?
Nickel is
You don't know? So you're going to find out what color is nickel. And then what color is chromate, what color is dichromate, what color is permanganate, and all of this. Is that okay? when you carry out the test. So here are questions for you to discuss. Discuss any of these color patterns with you can find in this samples. So any color pattern you find, you discuss. Okay, what color do you think the following compounds will be? Cobalt chloride, ammonium chloride, sodium chloride. So we normally do what we call the carry out the color test first, the flame test first, before we're able to tell which color each of these has. Is that okay? Is that okay?
Yes.
So I think we've gradually come to the end, but let's do the summary of what we have looked at in this chapter. Let's do a summary of what we have looked at in this chapter. So let me see. This chapter is about just a minute. Hey, let me reduce the size of the board. It gets too big. Okay, let's do a chapter summary. Let's do end of chapter summary to look at what we have described. And okay, let me try this purple color. So we studied matter. Okay, let's start with blue. We studied matter this chapter somehow because everything we've talked about, they are matter. So we studied matter. Then this matter is divided into what we call mixture and what we call pure substance. And matter is divided into mixture and pure substance. Pure, let me use a different color. Pure substance. Pure substance. So matter is divided into mixture and pure substances. Mixture and pure substances. And then here we have mixture. Let's put that for mixture. Let's use a different color. Here we have mixture. We have mixture and then we have pure substances. And then the pure substance is divided into elements and compound. This pure substance is divided into elements and compound. So let's change the color here. Let's use black first. This pure substance is divided into elements. It's divided into elements. Divided into elements, then compounds. Is divided into elements and compound. These pure substances are divided into elements and compounds. Now, other element contain atoms or molecules of a single element. Atoms. This one contain atoms. Change the color, right?
Yeah, you can use text. Just type since it's text. There's no one to
Okay, let's use text. Let's erase this one. Only this one. Okay, so we take text. So this one is made up of atoms or molecules of single element. Atoms or molecules of single element. Then it's also described by symbols. Okay, this one is also described by symbols. Elements are described by symbols. By symbols. Okay? Then, for compounds,
Yes.
they contain chemically bonded atoms of two or more elements. So for this one, for compounds, they contain now let's take a look at them one after the other. For compound, they contain chemically bonded atoms. Contain chemically bonded atoms of two or more elements. Of two or more elements. Okay? Then they also these ones are described by chemical formula. Described by chemical formula. They are described by chemical formula. And then proportionate, like for example, e.g. sodium chloride. Okay, they are described by chemical formula. CH4 and so on and so forth. Okay, HCl, sodium chloride, hydrochloric acid. All these are chemical formula. Okay, now again, compounds, the proportion of elements is mixed or is fixed in molecule. Proportion of elements is fixed in molecule. Proportion of elements are fixed in molecule. Okay, proportion of elements are fixed in molecule. Then, the last but not the least for compounds, elements can be identified by flame testing, or comparing colors. Element can be identified Elements can be identified by flame testing. Element can be identified by flame testing or comparing colors. So this is the summary this is a summary of what we have. This is a summary of what we have. Okay, this is a summary of what we have for matters. So you can see it, right? The whole chapter is about matter. We looked at molecules. We looked at molecules. We looked at atoms, molecules. We looked at pure substances, and then we looked at mixtures. We looked at naming compounds, and so on and so forth. In the part 1 of this, then to this one, which is part 2, we looked at the mixtures, the testing. Practically, we looked at the test, the colors, what the method the scientists use. That they use either qualitative techniques and or quantitative techniques to find out what elements are found in a compound. Okay, so we dealt with the compound. We say elements, they are made up of atoms or molecules of a single element. Atoms and molecules of single element. Then they're described by elements are all described by symbols. And then we went further to look at compounds. We say compounds, they contain chemically bonded atoms of 2 or more elements. The atoms of 2 or more elements are chemically bonded together. And then we say compounds are described with chemical formula, e.g. like sodium chloride, hydrochloric acid, H2SO4, H2SO4, which is sulfuric acid, and so on and so forth. And then we also say that compounds, the proportion of elements are fixed in their molecule. The proportion of the elements are fixed in their molecules. And then we also say the elements can be identified by using what we call the flame testing or by comparing colors. So this is what we have for this chapter. And thank you for joining us. Thank you.